Hello SGD, I'll put the link to the video I posted yesterday, which was based on these three types of pendulum. So very quick review, 1 second. So how to measure time in a consistent, like a way that could be transferred and be accurate. And it has always been the pendulum up until 1930s and quartz crystal. This pendulum is 0.994387 meters. This is the pendulum, the 1 second unit at 45 degrees north of the equator. As you move north or south of the equator, because of the variation between gravity, you have a slight variation in the length of the pendulum. So if you're at Paris, basically 45 degrees north, this was the 1 second pendulum. Of course, as mentioned earlier, the shallow angle of 30 degrees has been established as an important feature. So 1 second pendulum, this was going to be introduced as the American, so one American US yard almost became this pendulum, actually based on the second. It never quite come about, but that was the important feature. Okay, so that's a 1 second pendulum at 45 degrees. It changes ever so slightly depending on your location. This pendulum is exactly 1 modern meter long. This is called the speed of light meter. At that 30 degree section of arc is, by definition, it has to be pi over 6 meters, which is 1 Egyptian royal cubit, which was the unit of measure used in the construction of the pyramids. 1 Egyptian royal cubit, so 52.3 centimeters, was then divided into 7 palm or 4 fingers, so 28 fingers or 4 palm. As in Vitruvian Man, the foot and the forearm correspond, and so 1 Egyptian foot, let's call it, is 29.9199 centimeters. 1 modern, allegedly modern English foot, 12 inches, is 30.48 centimeters, a difference of 5.6 millimeters, which is an important feature because 1 meter minus 5.6 millimeters equals this pendulum here. And I also mentioned the Saxon yard, which was equipped. So 1 Saxon foot is 1.1 of these, 13.2 inches is a Saxon foot, which was used before this was introduced, which is exactly the same unit of measure. Some even suggest in Sumeria, but the Mohenjo-Daro or the Indus Valley. This too would create a very, very accurate pendulum. So the difference between the English foot and, let's call it the Egyptian foot, 5.6 millimeters. 1 meter minus 5.6 millimeters gives us the modern definition of a meter at 45 degrees. 1 meter plus 5.84 millimeters, it's a difference of 1/4 of a millimeter is the difference between those there. Now that would make this arc slightly longer, which turns out to be 1.7278 feet, which is again splitting a hair's difference between the canonical cubit, as it's been called. I would suggest that this is the origin of that and why it can be found in so many sites, let alone the numerical importance of it. But what I didn't point out was, well, this section of arc is 0.52066 meters, which is 27.3312 fingers, because you divide 12 thumbs is an inch, or 16 fingers would create. So that's fingers or inches, one of these difference. And that turns out to be 1.000899 Samian cubits. Samian, Doric and Ionic, as well as the allegedly modern English foot, can be found on a Salomon stone from ancient Greece. And if you apply that knowledge to various temples, such as the Parthenon, you get all these harmonic numbers. But this section of arc is a curve, okay? Now what we have is 52.066 centimeters. Now if we go to the unit based on the Mohenjo-Daro scale, the straight line across is 0.52066 109 mils. Now that's That's a difference of hundredths of a millimeter there. This is essentially like splitting a split hair, then you have to split it again to get this difference. The straight line across here, in all, again above 99.9999999% is this length of arc here. So what we've now done is to turn this unit and we've made a straight line of it, which again, it's the same. The straight line here is equal to the curve here. So here comes the problem. So what we have now is, well, 1 meter, that length, that arc is 1 Egyptian royal cubit. Now that's a curved line. How do you translate that into a straight line? What you would need to do is take this pendulum and add 5.67 millimeters. If I add 5.67 millimeters to this, the straight line across would be pi over 6 meters. This all blends together. Okay. Now, what else is important about this? So here we have the pyramid. Okay, well, seconds per day. So this is an important number. 86,400 seconds per day. Here in white, I have the pyramid. Now, I've exaggerated these slightly. What we have is at the corners, we have what's called the sockets, and the pyramid itself sits on a 55 centimetre high paving stone. If I multiply this distance, including the sockets, by 86,400 seconds per day, I get the equatorial circumference of the Earth. Or in other terms, this distance, maximum visible distance, including the sockets, is the rotation speed of the Earth per second. If I multiply the height of the pyramid, including the paving stones, times 86,400, I get the polar diameter of the Earth. So that's... Now what's interesting is that this is a Royal Egyptian cubit. This only describes the pyramid itself. If I multiply this by 440, I describe the pyramid. But if I want to find the Earth-based measure at 86,400, as in seconds per day, I need to multiply this number by 440. So whether it's 440 ERC or 440, that's canonical cubit, which I'd like to call the Mohenjo-Daro cubit. Now the difference there would be 0.001 foot, which is 1/3 of a millimetre. Basically, not much more than is even less maybe. Yeah, that's about, well, 1/3 of a millimetre again. So this particular unit times 440 gives us the base of the pyramid, including the sockets at the corner, which scales it to the size of the Earth. The difference between the Egyptian foot and the English foot, 5.6 millimeters. 5.6 millimeters minus 1 meter gives us the official 1 second pendulum at 45 degrees north. 5.67 millimeters, 1/100th of a millimeter difference, added to this pendulum would make the straight line exactly this number. So now we've turned a curve into a straight line, and now we can create a ruler very, very accurate from that. But as it stands now at 3.3 feet, it is again within 1,000th or even more of a millimeter, the exact distance which forms this arc here. So these margins of error will lead to beautiful, beautiful stuff, and it's all based on measuring length, measuring time. Now what's also interesting is the Samian scale, which is on the Salamis stone, just like the Doric and the Ionic, the height of the pyramid, just the pyramid, is 27.335 Doric rods. What's a rod? A rod is 16.5 feet, or half of 33, 3.3. So this is so whether it's in Bible stories, New Jerusalem, the measuring rod, Nuafu, Ningashida, Hermes, Sheshet, Thoth, using measuring. They're gods of weights and measures. And what you have is a coming together of time, length, architecture, and because of the Earth, so 45 degrees north would be this pendulum, and as you move north or south of the equator, you would have to adjust your pendulum length to get exactly 86,400 seconds per day. And again, these apparently separate, because Mohenjo-Daro and Harappa, they used a weight scale where one of the key weights was 27.3 grams, which is exactly the same as the Old Kingdom copper Devon. The numbers which so the moon is 27.3% the size of the Earth. The moon orbits the Earth every 27.3 days in regards to a star. So much that's covered earlier, but it's just through the margin of error, especially there are a few these systems will link, and I'll link at very significant, very important numbers. And this is a type of stuff you can check it on your, double check it, look at the sources, check the maths for yourself. What we find, 5.67 mils plus this would create exactly one Egyptian royal cubit as a straight line across. 5.6 mils minus a meter equals 1 second pendulum. That's gone a little bit longer. That's why. Would create a 1 second pendulum at 45 degrees north. And also worth noting that this has to be 30 degrees. Anything more than that will affect the timing. Well, Giza itself, the plateau, is 30 degrees north. Now, the Great Pyramid is slightly short of 30 degrees north. And how much? Well, the base of Egyptian royal cubit times 440 equals the base of just the pyramid. Egyptian royal cubit times 4,400 equals the distance that the Great Pyramid is short of exactly 30 degrees north. Now, the 360 degree compass, we're familiar with that. There's also another radian, which is another way of measuring circles, the angles. It just so happens that 30 degrees is pi over 6 radian, and one Egyptian royal cubit is pi over 6 meters as well. So there's another lovely connection, because at 30 degrees you're at pi over 6 radian, you're 4,400 pi over 6 meters short of that distance to be to the very center of the Great Pyramid. 86,400 seconds per day times the maximum visible base and the height of the pyramid gives you the polar diameter, as well as the equatorial circumference of the Earth, rivaling until the most recent satellite age. So time, measure, architecture, these margins of error, instead of rounding off, if you look at these and apply these, it will just continually link and blend in to one another. And this is what, so especially if you're a global civilization with trade, think of the English Empire. They weren't using modern technology. They had to navigate, measure. Well, the same tools, that were basically, except for the telescope maybe, but were available to them. Tools such as this are exactly the ones that would have been available to an ancient global trade civilization, because the Mohenjo-Daro units of weight and measure correspond to the Old Kingdom, and also they link wonderfully with the Sumerians. We also see evidence of it in the Vinca culture, Varna culture of Old Europe in Bulgaria, which predate, which go back to 3500 BC. We find the Egyptian royal cubit in the Varna culture. The Varna hoarders was found in Bulgaria, which also incorporates the same geometry of the Great Pyramid in these golden tablets that they had, golden plates. So yes, there's still more to go with this, and I'm gonna, I need to create these videos, so I've got a basis. I'll be using these as an example with some other still images and showing how the meter coincides with the Mohenjo-Daro or Saxon yard come back to very important numbers, linking very important sites, essential architecture, legends, so it's all blended in there together. And of course, this can be measured, so that it needs to be. You pile up the coincidences, and the probability starts, extending out. The improbability of this being a coincidence starts mounting up and extending much further. So weights and measures, man is a measure of all things. The Great Pyramid is just one example. That what you'll find in the Great Pyramid is also in other sites. Now, okay, might as well mention, since I'll do a video on this, but Notre Dame Cathedral, what they found was a unit of measure which Stefan Lefringe called the royal foot. I'm going to call it the medieval royal foot, not to be confused. The medieval royal foot was essentially, within splitting hairs, 333 millimeters. So one medieval royal yard would have been 1 meter minus a millimeter, and that's within the margin of error. So this 1 meter pendulum can be found in Notre Dame Cathedral and Beauvais Cathedral and other cathedrals as well. Just as an example that this has been transmitted across time. And so, for instance, one of the early, when Mersenne and Riccioli were looking at this original 1 second pendulum, they were using this as a metronome to time the choir. So as the second as an important unit of time in many aspects as well. But Egypt, the allegedly modern foot and meter, as well as the Mohenjo-Daro units, if you look at them through the pendulum and the second, the arcs and the lines and the units just will describe all these different features and bring them together. And so what more can, so I'll be using this video as a background for some other upcoming episodes, because it still relates back to what I've been working on in this particular series in the last few episodes, the importance of the meter and how it corresponds to the foot, and how that corresponds to sun, earth and moon inherent measures, as well as the cellular stones, same in Doric, Ionic, all comes together at these, especially 27.3 or 29.35 days per synodic month or full moon. So yeah, measures of sun, earth and moon, measures of time via the pendulum, ancient units, across ancient cultures. Just it's either, it was either designed, or it was the most extraordinary coincidence since creation, and that's about the only way you can really think of it. Because there is no, to say coincidence, or to say it doesn't happen, that it's impossible because we've made an assumptions on what was done. Well, this can be done with math, geometry, and the same tools that the medieval and Renaissance people were working with. They didn't have computers, they didn't have lasers, they had cross staffs, rulers, mathematics, and observation, experimentation. And so pendulums, the second, feet units, not just the English foot meter cubit, but also other units such as the canonical, Doric, and Ionic, all coming together. Earth-based geometry, earth measure. Geo is earth, metry is measure, otherwise known as geodesy. But there it is. Measure, the wisdom of Hermes, Thoth, Shesset, and these other gods of weights and measure, gods of math, though also the gods of architecture and astronomy. And well, what do you get? It all comes together: math, geometry, measure, astronomy, sun, earth, moon, the planets as well, as I covered in the earlier video as well. And okay, let's say it was a coincidence. Well, very well, but then here we have a method for encoding information that could be taught. It can be done, experimented at home with, and so at the very least, I think it's profound information in that sense. But I don't believe the synchronicities, coincidence just keeps building up to a point where no, it can't be. It has to be designed because, for instance, 30 degrees is 108,000 seconds of the compass. This also applies in so many aspects in regards to astronomy, speeds of distances, rotation periods of planets, etc. Yeah, okay. Have a good one.